Good morning, everybody. Welcome to our first day on actually solving equations. We finally got here. This is kind of what algebra is all about. So we've talked a lot about writing expressions, simplifying expressions, writing inequalities, like terms, a bunch of kind of lead up stuff. Now we're going to actually kind of start putting some of that stuff together a little bit at a time and start solving some equations. Okay. So there's a couple of things you're going to hear me say. And so I want to highlight what those things are right off the bat. So you're going to hear me talk about inverse operations. So when I talk about inverse operations, I'm talking about opposite operations. So I'm talking about what will undo something. So an example is if I were to add a number and I wanted to undo that to get back to where I started, the way I would do that is by subtracting. So the opposite of addition is subtraction. Okay, if you think of a number, add 10 to it, and then subtract 10, you'll end up back where you started. Okay, because those undo each other, right? Because subtraction is just adding an opposite. So subtraction, the opposite of addition is subtraction, and the opposite of subtraction is addition. Kind of same way, right? If I were to subtract 10 from a number and then add 10, I'd end up where I started. Okay. Well, what about multiplication? What is the opposite of multiplication? Well, the inverse of multiplication is division. Okay. If I were to multiply by something and then divide by that same thing, I end up where I started. Okay, so multiply by 3 and then divide by 3, and you'll end up where you were. So the opposite of multiplication is division, and vice versa. Okay. All right. The one that you might not think too much about is squaring and square roots. Squares and square roots are also opposites, right? If you take a number and square it, like let's say you take 5 and you square that, that means you multiply it by itself. Well, 5 squared is 25. Okay. Well, if you have 25 and you take the square root, that'll get you back to 5 because the square root says what number would you have to square to get that number. Okay, so squaring and square rooting are also opposites. So some of those will come up too. Okay, so the steps that we're going to be doing, and these are ones you want to have down. To solve the equation, there's going to be 3 steps. And when you're doing this, I want you to think of a balance scale in science. Like hopefully you've seen scales like this at some point. The idea is you need to keep both sides of the equation equal. So an equation is a lot like a set of balance scales. Okay? We're going to use what I call train tracks to separate the sides of the equation. And what that's doing is just isolating the 2 different sides so we make sure we're keeping it balanced. And you'll see what I mean by train tracks in the first example. Okay, once we've separated with train tracks, step 2 is you're going to do the opposite or the inverse operation. Okay, so we're going to get rid of what we're trying to get rid of. We're going to undo whatever's been done to our variable to try to get the variable all by itself. And we're going to use the inverse operation to do that. Okay. Step 3 is you need to do the same thing to the other side. That's very, very important. So the idea here is, if you think about this scale, if you add 10 pounds onto one side, it's not going to be balanced anymore, is it? But if you add 10 pounds onto both sides, it's still balanced, still equal. Okay? Same thing if you take away weight. If you take away weight from just one side, it'll not be balanced anymore. But if you take away the same amount from both sides, it's still going to be balanced. Okay, same thing with multiplication. If I double the weight on both sides, it'll stay balanced. Okay, if you cut the weight in half on both sides, it'll stay balanced. So any of these operations, we can do anything we want to both sides as long as we do the same thing to both sides. Okay, so you'll see what I mean by that. But these are my steps, so make sure you have those down. All right, let's see what this looks like. Before we do, just a quick reminder of your integer rules. We're going to be dealing with positive and negative numbers here, so we need to know how they work. Okay, we're going to deal with addition and subtraction today. We'll deal with multiplication and division tomorrow. Okay, but remember, or no, sorry, not tomorrow, a couple days from now. So when you're adding and subtracting, remember if the signs are the same, you're going to add the numbers and keep the sign. Okay, a negative plus negative will give you a bigger negative. If the signs are different, and this is the one that people screw up most, you're going to subtract the numbers and keep the sign of the bigger one. So you're thinking, is the positive or negative bigger, and by how much? That's what we're doing here. Okay, we'll have simpler rules for multiplication and division when we get to that. Okay, but hopefully remember those. All right, so let's do my steps. So step one, train tracks. Here's what I mean by train tracks. I'm going to underline, and I'm going to take the equal sign and just draw a set of parallel lines alongside of it. Okay, this looks kind of like train tracks. Okay, and the reason I'm doing that is to separate the left side of the equation from the right side. So here I have an equal sign. This is like my balanced scales. I got one side over here, one side over here. And because they're equal, the scales are in balance right now. I need to make sure they stay balanced the whole time. Okay, so I'm going to do step 2. It tells me to do the inverse operation. So right now, x had 14 added to it. So I had some number, I added 14 to get 25. What I want to do is I want to undo that so that x is all by itself. Now, some of these are going to be kind of obvious ones you can do in your head, but again, the important thing now is not just being able to solve this in your head, but understanding this process of equation solving, because this is going to apply to every equation you ever deal with, no matter how complicated it gets. And I guarantee you, when there's square roots and fractions and all sorts of crazy steps involved, you're not going to be able to do it in your head. You're going to need to understand this process. Okay, so I'm going to get rid of plus 14 by subtracting 14. Okay, there's the inverse operation. The opposite of addition is subtraction. Okay, and then step 3 says to do the same thing on the other side. Okay, so I subtracted 14 from both sides. If you think about a scale, take away 14 pounds from both sides, it's going to still be balanced. Okay, because you did the same thing to both. Okay, so here, if I had x on added 14 and then took 14 away, those inverse operations are going to cancel out, and all that's going to be left on this side is my number that I started with. Okay, so I got x by itself, but then I got to do the same thing here. So 25 minus 14 is 11. Okay, so I get x equals 11. Okay, if I want to check my answer, the way I can do that is take what I got and do the evaluating stuff that I did before. So I'm just going to plug it in for x and make sure this is true. So if I make x 11, 11 plus 14 is 25. So it does work. Okay, so that's a good habit to be in, checking as you go, at least to make sure it makes sense. All right. Why don't we pause here and see if you can do these two. All right, welcome back. So if we do these steps, we got train tracks. Okay, I have x plus 8. So the inverse operation, the opposite of adding 8 would be subtracting 8. Okay, step 3 says I have to do that to both sides. So I got minus 8 from both sides. Okay, the plus 8 and the minus 8 cancel out, leaving x by itself. 13 minus 8 is 5. So I get x equals 5. If I plug it in, 5 plus 8 is 13, so it works. Okay. This one with this negative number might have been a little trickier. Again, I'm doing train tracks, step 1. Step 2, do the inverse operation. So I had r minus 13. Okay, subtracted 13 from r. The opposite of subtracting 13 is adding 13. Okay, so that's going to cancel that out. Okay, step 3 says to do it to the other side as well. So both sides are having 13 added, so it should stay balanced. The minus 13 and the plus 13 cancel each other out. And I just have r. Negative 18 plus 13. Here's where I have to remember my rules. So the negative is bigger than the positive, so my answer is negative. Then 18 minus 13 is 5. So this is 5. The negative number is 5, bigger than the positive number, so they add up to negative 5. All right, let's try a couple more. Train tracks, step 1. Minus 3. The opposite of minus 3 is plus 3. Got to do it to both sides. So adding 3 on both sides. The minus 3 and the plus 3 cancel, leaving r by itself. Okay, and negative 11 plus 3 is negative 8. And the negative number is bigger. If I subtract them, I get 8, so negative 8. Okay. All right, let's try this one. W plus 18 equals 52. Okay, so train tracks. What's happened to my variable is I had 18 added. I'm trying to get this by itself. So I need to get rid of this. I do that by subtracting 18. But I have to do it to both sides. So the 18 and minus 18 cancel. 52 minus 18 is 34. Okay, so 34 plus 18 is 52. Okay, I forgot to check this one, but if I plug in the negative 8 minus 3 is the same as negative 8 plus negative 3, which is negative 11. Remember, negative plus a negative is a bigger negative. Okay. All right, one more here. So train tracks, 5 is being added. I'm going to subtract it. Subtract it from both sides. So you get W equals negative 9 minus 5. Remember, I'm going to change that to negative 9 plus negative 5. A negative plus a negative is a bigger negative. I get negative 14. Okay, plugging it in. Negative 14 plus 5 is negative 9 because then they have different signs. The negative is bigger, and it's bigger by 9. All right, so that is all the ones that we're going to do today. So you can get a little bit of practice with this equation solving process. Tomorrow, we're going to start throwing in a little more complicated numbers, decimals, and fractions, and making sure we can still do the process even when the numbers are not quite so pretty. All right, good luck.